Good evening, everyone. Here we are having Samuel with us. He is presenting his topic, The Security of Debian, an introduction to advanced users. He is a senior system development engineer in Amazon Linux, and he is developing Rust and Python-based systems that deals with CVE processing at AWS. He is also a Debian developer and contributing mostly to packaging of security tools in the Debian Security Tools packaging team. So we welcome you. So now time starts. Thank you.
Thank you for coming to my talk. Last year, I presented fixing CVEs on Debian at DebConf in Busan. That presentation can be used as a reference for anyone who would like to contribute security fixes for Debian. This year, I would like to expose users to the way we handle security vulnerabilities in Debian. I have personally noticed that even experienced users or maybe contributors as well do not realize the way these are handled on Debian. People usually miss the idea of backports, for example. And so these slides are available in my website at samueloph.dev/slides. The website, I'll spell it out for you, is Sierra Alpha Mike Uniform Echo Lima Oscar Papa Hotel.dev. My name is Samuel Henrique. I am a Brazilian, but I have been living in Ireland since 2018. I am also a developer, a Debian developer since 2018. I contribute on my own time on a personal basis, so I do not get paid to contribute. I am a member of the Security Tools packaging team, which is the team that maintains security-related tools in Debian. You can think of stuff like Nmap or Aircrack NG. So a lot of the stuff we do there gets pulled by Kali Linux, for example, and we do have some Kali Linux employees that contribute to the team as well. Outside of that team, I maintain a bunch of other packages. The most famous ones would be curl, rsync, and possibly shellcheck. I do a lot of mentorship work for newcomers, especially within the Debian Brazil community. But this year especially, I am a Google Summer of Code mentor. And as my job, I am a senior system development engineer for Amazon Linux in the security team. But I'm giving this talk with my Debian developer hat on. My socials are SamuelOPH. You can find me pretty much anywhere. I'm gonna first start with a brief introduction to what are CVEs, since most of the time when we talk about computer vulnerabilities, we are talking about CVEs. There's a big overlap there. I'll tell you what is the level of support that Debian promises for the releases, and then we get into how Debian analyzes fixes and distributes those fixes. At the last part of this, I'll give you some tips on how to perform your own investigation. I'll show a few examples of common mistakes that people tend to make, which is the stuff that I keep saying it. And I'll give you some very simple but effective good practices to have a more secure system. First of all, there are different areas of security. Security is so broad that I have to at least acknowledge what are the areas that I'm not going to talk about, because this is very specific. So if you think from the point of view of infrastructure and governance, for example, that will have to do with how Debian manages its own infrastructure, for example. So who gets access to what, how are these systems patched, and so on. And then thinking from the point of view of distribution of software, you can bundle package ingestion, package building, and package distribution as the same thing. Of course, it depends on your threat model, but usually you can look at those three things and see that the main concern there is of keeping the integrity of what we distribute. We want to make sure that whatever source code we pull from upstream is what ends up installed in the user machine. And there's a lot of places this code passes by before it gets there. And then you have, of course, also incident response. There are other areas. The focus here is vulnerabilities in Debian packages. which I would say is the main thing for a user. Of course, you care about all of this, but this is the thing that you are exposed the most. So the CVE program, possibly a lot of you are already aware of what it is, but this was created in 1999. It's somewhat recent. It was done by Maitre, which is a not-for-profit organization in the US, and it is mostly or 100% sponsored by the US government. They created the CVE program, and the main thing that this program does is the coordination and assignment of IDs for vulnerabilities. Those are the CVE IDs. The format that they follow is CVE-year - a certain number, and they are unique, meaning that the same vulnerability will have the same CVE ID regardless of which system it affects. So if there is a flaw on Firefox, Firefox on Debian, Firefox on Fedora, Firefox on macOS, on Windows, they will all have the same CVE ID. And that makes it much easier to coordinate discussions, fixes, anything that you have to do with it. Any person can request a CVE ID. There is a process for doing that, of course. Usually you report first to the developer of the software, but the point is you don't need any credentials to report a CVE ID. And the CVE will only really be an ID and a short description of what it is about. But then you have these other organizations that will enrich the data. NVD is the most famous one. NVD stands for National Vulnerability Database. It is a program by this American institution called NIST, and they will add a severity and a score to a CVE. This is very important because for a lot of organizations, the SLAs for patching, for remediation is centered around the severity of the CVE. And the way the scoring happens is through something called CVSS. It defines this framework for scoring vulnerabilities, and it's centered around properties of the vulnerability. So, for example, if you look at the attack vector, it could be local, adjacent network, or physical. So you set the right property there. You have attack complexity that could be low or high. You have impact metrics, which could be low or high for availability, integrity, confidentiality. Once you set all of those properties up, you follow the math that is defined by CVSS. You end up with a score that is between 0 and 10. And out of that, you get a severity that has 4 levels. It's low, moderate, high, or critical. Besides that, you also have vendors that will publish their own assessments of those CVEs. And these vendors, at least any big Linux distribution will have this, their own websites. For Debian, that is the security tracker, and that contains all the information you need about the CVE for Debian. I've listed the one from Amazon as well, Explore Alas. You have Red Hat has one, Canonical has one, SUSE has one as well. And another thing that is interesting out of the CVE program is the CWE enumeration. So they also enumerate weaknesses in software. For example, use after free receives an ID, time of check, time of use receives an ID, buffer overflow gets an ID. And then you can start labeling vulnerabilities with these IDs and get interesting metrics out of them. The last link there, it's the list of the top 25 weaknesses out of 2024. So you can see what are the common mistakes that people are still making it today. There's a lot of C code there. And cwe.mitre.org also contains a lot of examples of bad code for those CWEs. It's a really nice educational resource. There are alternatives to the CVE program. This is a bit of a hot topic right now, but GitHub should be especially mentioned here. It's not mutually exclusive to CVEs. They tend to go hand in hand, but GitHub does a good job at integrating that in their UI, and they're also very quick to release advisories. There was a fork of the CVE program more or less recently. The fork died off roughly 2018. It's called DWF. This fork it is a fork because it was reusing the same ID format of the CVE program, so there was a risk of a clash there. They created this because Mitre was just taking too long to release those IDs when you requested them. And then you have programming language specific advisory. So Rust and Golang, they do a great job because they also provide information in a machine readable format, which lets you create scanners that will identify exactly what is the function that is affected. And then you can do a scan through other source code and flag whoever carries the affected version. And there are geopolitical entities that also have came up with CVE alternatives, but none of them come even closer to the influence that the CVE program has today. The European one might catch on some moment now, but we see so far it's the whole industry centered around CVEs. So what does Debian promises as a support then? You have by default, for every Debian stable release, you get 3 years of support provided by the security team. You don't have to do anything, just keep using Debian and updating your machine. After that, you will get 2 more years of support. So now we're talking about 5 years in total. Again, you don't have to change anything, you just keep using it. After that, you probably should consider updating to the newest release. You're gonna be 2 releases behind by that time. If you still need support, then there is the ELTS team that provides 5 more years. And this is not officially part of Debian, but it is provided by a company that was created and is composed of Debian developers. The company's name is Friction and is also a sponsor of DebConf. It will require using an external repository because it's not in the Debian infrastructure, and it is paid by their customers, but they do provide it for free to everyone. So the recommended thing here is that if you need to use this, your company, you should pay to keep this alive. If you can pay, it is available for everyone. And then you get 10 years of support in total. It takes a lot of work to support these old releases. This graph that I took from the wiki page has a nice visualization in what it's still supported today. Oldest release that's still supported is Debian 9, Debian Stretched. It was released in 2017, and it will be supported until 2027. And that's by ELTS. So these CVEs are constantly coming from Mitre's data pipe, or it's the fire hose. And the security team of Debian has set up an automation that is constantly importing this data and sending it to a sort of queue where it has to be triaged. It can be triaged by anyone. Also, if anybody is interested in this, talk to me. I can help you. I can teach you how to do that. But it's usually triaged by the security team. It is constantly happening. It happens day and night, weekdays and weekends. And the investigation work that needs to be done there is pretty much check what versions are affected, what packages we ship on Debian that are affected. And in order to find that out, it's a very cool investigation work because you have to read about the vulnerability, you check the patch, if there's one, you start investigating the source code, and you try to identify what is the break commit, what is the commit that introduced the vulnerability, because once you have that, you also know what is the range of affected versions. You can confidently say it starts here and stops here, and by doing that, you might be able to take out Debian old stable, for example, because it's before the impact started. Now, if we ship an affected version, we still need to check if it affects the actual package we have. There might be circumstances where it's for a certain CPU architecture that we don't support, which is a bit rare because Debian runs on everything, but it might still happen. It might be mitigated by a build flag, so maybe it's an experimental feature of the software that we don't build for Debian, and thus we are not affected. So as a reference there were 40,000 CVEs published in 2024, so you can see all of this work in the Security Tracker Git repository, but the best interface for users or for people that are not contributing is the Security Tracker website, and in there you can see it in a proper human, more human readable way all of the investigation. You will see which versions are affected, which versions are fixed. If you use ELTS, you need to refer to Friction's version of the security tracker, which uses the same system, so it's the same UI, but it has the data for these old investigations, all the releases, sorry. There's also the embargo process, which is the most fun thing about the whole process. There are a few embargo processes out there, and the embargo process is a way of getting a bunch of representatives of big vendors, big Linux distributions, to talk about vulnerabilities that are not public yet. So they can coordinate and get the fixes already for when the vulnerability is published. The most common, the most famously known embargo process, embargo group that is out there is the distros mailing list from openwall.com. And the Debian security team is in that list. There are representatives of all the big Linux distributions there. The subscription is extremely restricted, so Debian only has like 1 to 2 people. What happens is once they receive something, they might decide to handle it themselves, or they might forward it to the package maintainer. And so I receive, for example, I tend to receive embargoed CVEs from the curl project because they always follow that process, and roughly every 2 months there might be something. Oftentimes we decide not to patch it straight away because it's not important, so there's no need to rush. And as a reference for how frequently this happens, it would be safe to assume there is an embargo going on right now. It's safe to assume there is at least one embargo going on at all times. This is what the security tracker looks like. This is the view for a package, for the curl package. You will see the versions that are shipped, and then you get open issues. Issues in this context are the vulnerabilities, and you get to see which are the ones that have not been fixed yet in a certain release. And then in the center part of the web page, you see the resolved issues. So those are the ones that have been fully mitigated already, remediated. And then you also get the concept of unimportant issues. The security team might mark some vulnerabilities as unimportant. And notice how every CVE ID is a link. I'll show you that later. There's another view for the CVE which will give you more details. And it's important to note here that the security tracker is not tied down to CVE IDs. It does work with any sort of ID. If there is no ID out there, we will create a temporary one. So it's not hindered by that. Now, the main thing that I mentioned in the beginning that people don't understand is why Debian backports fixes. And some people even don't understand that this is going on, that Debian is backporting. So if we think about this fictional scenario where you have a software developer that is preparing version 5 of their software, they've gathered a bunch of changes, they refactor a bunch of code, someone reported a vulnerability, they apply the fix and ship everything as version 5, and they don't care about version 4 anymore. And then on Debian we have an issue because we might be shipping version 4 and version 3 and stable and old stable. And then some users will think that they need version 5 in stable, but they don't want that really because it might break their whole application. It could be that version 5 requires a lot of configuration changes for whatever use case they have. It could be that they need to rewrite their application to use this new package as well. So what Debian does here, this is not just not suitable for Debian stable. We will backport the fix, and backporting here is the process of going over to version 5, identifying what is the fix, the minimal fix for the problem, and then we pull those changes to version 3 or version 4, whatever version Debian has. This also means that the fix will not come as version 5, it will come as version 4.0 or 3.0, whatever, and then the Debian revision part of the version will have Deb 12, Deb 11, update 1, update 2. Depending on the severity of the issue, Debian will release advisories, at least for stable and not stable. The vulnerabilities that are more serious will be patched through with an advisory. And the advisory is nothing more than this official notification that something was fixed. A single advisory might fix more than one CVE. The advisories for stable are called DSAs, Debian Security Advisory. For LTS, you have DLA, and ELA for ELTS. Depending on whether or not there is an advisory for that fix, it means it's distributed from a different place. So CV fixes that contain an advisory will be shipped through the security repository, and that means it's available straight away. If it's not that serious, if there's no advisory, it will go through the proposed updates mechanism, and this means it's only available to the user once there is a point release. And point releases on Debian, they have happened every 2 months in the last years. So it takes up to two months, and it goes together with other types of bug fixes. It's not serious enough, so it follows that other process. This is what a DSA looks like. It's pretty much an email in an announcement, the mailing list. This is the case for rsync, where we had a bunch of CVEs earlier this year. So this DSA will explain what is the package, what are the CVEs. You get a description of what is the CVE, so you can get an understanding of how serious it is. And at the bottom of that, there's also the exact version that is related to that advisory. What is the version that fixes it? And of course, a cryptographic signature, so you know it's coming from the security team. I have not spoken anything about experimental unstable and testing yet. The reason for that is because there is no official support, security support for those releases, for these development releases. But the matter of fact is that they all get fixed in a timely manner. At the end of the day, we, the developers, we are using these releases, unstable and testing. We care that the vulnerabilities are fixed quickly there. So as a reference, in the case of the XE backdoor and these rsync CVEs, they got fixed together with stable. It took roughly 24 hours for one of them to go from unstable to testing, because there was some time to build it and allow list the migration, but the fix reached unstable straight away, and it didn't take long for testing. So there are no promises there, but it's more secure than a lot of distros out there. On this diagram, you can visualize the different places where you can get a CV fix. So if it comes through stable security, which is a repository that is enabled by default on Debian, it means there is a DSA attached to it. Otherwise, it will stable proposed updates. You can enable that repository if you want to get it fixed early. Otherwise, you just wait for the point release. That repository, by the way, will carry a bunch of other bug fixes. There are certain reasons to not fix a CVE, because at the end of the day, this is a matter of doing risk assessment. Is it more dangerous to try to fix this and risking doing something wrong than to keep the vulnerability there? And it always depends, but there are times where we decide not to fix something because it's just too risky. There are some times where it's just not important enough. Nobody wants to waste time on doing that, and then any volunteer, anybody can contribute the fix. Those are good candidates for people that want to start contributing with this. Sometimes it's just not a real security vulnerability. An interesting case that happens sometimes is with vulnerabilities that comes from fuzzing. So in fuzzing, you usually target some internal function of a project, and then you pass weird parameters until you trigger a state of buffer overflow or something like that. And then you get a CVE. But then after further analysis, you realize that from outside of the application, it's impossible to trigger that internal state with the available inputs that you can do. And so it is just not a real CVE. There are some cases where it's arguable whether that matters or not. Malicious files that don't open on Vim. There are some, usually they do become CVEs, but then they get a lower priority. And so an example of something that is obviously not a CVE, but it kind of shows how we have to think about this is a fork bomb. So you can do a fork bomb on Bash or other shells as well. Is that a CVE? There are some cases where it's a bit unclear. Some cases it's more clear that it's not. The CVE might get rejected, but it might not get rejected. If it doesn't get rejected, we might not fix it as well. The fix might be too complex, which is the initial case I've mentioned. And the fix could be actually removing the feature. It has happened a few times that you have software that supports different network protocols, and then they find a vulnerability, and Upstream says, you know what, I'm just going to remove this feature, and it is fixed, and it is a proper fix from the Upstream's point of view, and it is valid. And what we do on Debian, we can't really just yank out a whole feature on stable. I mean, it depends. You need to do an analysis there and consider what is worse, right? If the vulnerability is really bad, of course we're going to remove it. But if it's not, it's going to stay there, and then it gets removed in the next Debian major release. We have a small problem on Debian today with vulnerabilities that are in the source code but not in the binaries, because Debian is the only distribution that is very precise on the assessment and will say that that the source code has the vulnerability, but the binaries do not. But then we have a tooling issue where we end up saying that the binaries are also affected. This is about to get fixed. I sent a proposal for this maybe 2 years ago to the security team. We discussed it a lot. There was an agreement on the path forward. The Friction folks, they came to this conference, and during DebCamp, they did the whole implementation, so I didn't have to do any implementation work there. We're waiting now for the security team to review and possibly merge that. Once that is done, I can go after all of these CVs that I know are false positives and flag them all down. I have done a small investigation work some time ago on the Debian container image, and I found out that there were roughly 20% CVs that fall under this case that are false positives. So I'm really excited to see this change, because it means a lot of container images are based on Debian, and all of those are going to get like 20% less CVs once this is out. This is the security tracker view for a certain CV ID. There's a lot of information there. The main thing to pay attention to is the source field. It has a lot of references to other sources of data. It's extremely useful. You get NVD, which has scoring severity. You get other distributions as well. LWN is there, so you can read news about CVs. Some GitHub links as well. You see pull requests issues with the same ID. And in the center part of it, you also get an overview of which packages and which Debian releases are affected. In this specific case, curl is still affected in Bullseye, but it has been fixed in all the other releases. And you can also see what is the version that has the fix. If you go to the bottom part of that same page, you see the notes section, and usually they tell a story there. So in this case, you can see that for Bullseye, it is ignored because we don't build curl with HSTS. It turns out that in order to exploit this, you need this enabled. We don't do it. This is the problem I was talking about. The vulnerability is in the source code. It is not in the binary shipped by Debian. In 2024, so all of these numbers are from CVEs released in 2024. We've got 40,000 CVEs. Out of those 40,000, there were 255 DSAs that mentioned them, and 2,046 CVEs were fixed. All of those. That is, we're talking 5% now. Similar numbers for old stable. CISA, this American cybersecurity agency, they have something called KEV list, non-exploited vulnerabilities. They are constantly monitoring the world and documenting exploitation of vulnerabilities. Once they have confirmation, they add it to this list. Any CVE that they add to this list raise a lot of alarms in a lot of companies out there, because it pretty much means you have to patch this yesterday. But out of those, at least 93 doesn't have anything to do with Debian. They are for other random products like maybe Microsoft or firmware, router, some other non-free software project. So we have 56 left. The important thing here is that CVEs that are outside of this list, they are still important. I'm not saying we should only look at those, of course. CISA have taken extra time, a little bit too much time to add CVEs to this list in the past, sometimes 3-4 months for something that was clearly being exploited. But it does show you a picture here, because the number of CVEs we care about is somewhere in between, right? And then you start with 40,000 and it tunnels down to such a low number. And by the way, the script to generate these numbers, it's there. I have seen different numbers being published in news. I'm not sure why, but this should be the right number, and this is the source to generate them. So what if you want to do investigation yourself? Maybe you heard about a CVE and you're concerned. Start with the security tracker. The security tracker is where Debian posts the details. That's where you're going to find out that you might not be affected. Check NVD for extra references. NVD will reference news articles, for example. And NVD is also referred in the security tracker. So from the security tracker, you get to NVD. For NVD, you get to a lot of other sources. There's a few tips to identify serious CVEs. So, of course, they are rapidly notified in tech news. So you're going to see it, Hacker News, LWN, Phoronix, all these places. If they are very serious, they tend to have their own name and logo, which is funny, maybe a bit silly, but there is a practical aspect to this, which is that serious CVEs stay relevant for years and nobody will recognize the CVE by the CVE ID 2 years later. I'm sure everybody here has heard about Spectre, and I would be willing to bet nobody remembers the CVE IDs attached to it. But also, if they are very serious, they were very likely part of an embargo, and also very likely Debian was involved, which means that by the time you see a news article about something, the fix is already out. You just need to update your machine. And how do you find that out? Security tracker. There is a very small chance that you open security tracker and there's no information yet because there's a delay there. So the fix will go out first, and it might take a few hours for security tracker to update its information. So you can also check the package changelog, update the package, check the changelog. It's going to tell you what happened there. Pay attention to all the mitigating factors around the CVE. Sometimes in order to actually be exposed, your machine needs to be directly connected to the internet. Sometimes it might require a very specific configuration that does not come by default. And of course, you still want to fix the problem in those cases, the CVE, because it could be that someone changes the configuration and now you're exposed. But you need to understand if you're actually exploitable at that point in time. And be very critical of the description that you see in the CVE. They tend to imply a lot of things that are not true, and that catches a lot of people. So for Wireshark, for example, this is just an example. This is not specific to Wireshark. It happens with a lot of projects. They list that the affected versions here, it's a little bit confusing the way it's written down, but it's between 4.0.0 and 4.2.0 it's affected. And then you might think that you're safe using version 3, and that is just not true because Wireshark might not be supporting version 3. They don't even list it. How do you know whether you should care or not? Security tracker. It will tell you if version 3 is affected and if there is a fix. Sometimes you get descriptions that recommend users to update to a certain version. So users should update to version 2.4.62. And let's say they're running 2.2 for this. They might get desperate and update it by themselves, pulling something from the internet, manually compiling the project, and then they just break their application because they need to change the configuration, they need to rewrite something else in order to use the new version. They don't realize that distributions are backporting fixes. So the security tracker will tell you that. Good practices. Everybody here is using Debian, but I mean, understand if you use something else, understand what are the security practices behind that. There are some distributions that don't do really a great job of this, and you don't realize it until it's too late. So, of course, distributions will pull the patches from Debian, but maybe there might be something wrong there. They accidentally don't pull the fixes as well, or they take too long. So I'm not thinking about any distribution specifically, like all the famous ones are fine, but then you get random distributions that are really risky to use. Update your machines frequently. The main risk that we all run is not 0 days, it's a bunch of machines that have not been updated. I have seen some wild stuff out there. You should update your machines. Don't let it become an update for weeks. Understand when you have to reboot your machine. You are not supposed to run kernel live patches forever. Even if you patched something, some other package that is not a random package, you might need to reboot it if there is a process holding the vulnerable version in memory. And yes, you can kill the process, restart it, but then depending on the severity of the problem, you're taking no risks, you're just rebooting the machine. It is important to understand that this is a risk, at least. Pay attention to unofficial stuff you install on your machines. It's very common nowadays to install IDE plugins, new Vim extensions, by the way, and they come from random places of the internet. If someone tampers with them, are you gonna notice? And if there is a vulnerability there and someone pushes the fix, are you gonna pull the fix? So you're working with a whole different threat model now. And I'm not saying don't do this, because I know it's a lot of people do. I know it's required, but you just need to understand how you're changing your risk when you do something like this. And you should probably uninstall packages, services that you don't use. You should not go as far as uninstalling things that comes by default on Debian, but if you install a bunch of stuff yourself and you don't use it, it might be a good idea to remove it. You just become much less exposed to risks there. Summarizing, Security Tracker is the canonical source for vulnerabilities on Debian. Debian will backport fixes. It will not just package the latest one. If you have an affected package installed, it doesn't necessarily mean you have an affected system. Do your research. A lot of CVEs are just noise as well. The important fixes will have an advisory and come through the security repository, so you can pay an extra attention to the DSAs and update your systems whenever you see one. And be careful with like other systems you might be using. So I don't think we have time for questions. Let me check. Do we? Okay, we might have time for 1 or 2 questions.
Thank you for this insightful presentation. Now the questions.
Kind of 2 quick related questions. So you mentioned like some of the random distros don't have good security. Are there other Linux distributions that you think do have good practices, and are there any practices that you'd like to see Debian adopt from other distributions?
Let me think. I think Debian tends to fix less. In some cases, Debian used to fix less CVEs than other distributions. That is changing. I can't say where it stands right now, but it might be on par already with other distributions. I don't like the problem that Debian has where we over-report on CVEs, on these false positives. I think it would be nice to be a bit more aggressive on these issues, but change is happening. It's just because we are a volunteer organization. Now there's some help coming from Friction as well. So I would like to have a little bit more progress on reducing the number of CVs that we report or that we have open overall, especially for the container images.
Any other question?
newer architectures, how do we get LTS support? Say, for example, RISC-V.
That depends on Friction's customers, really. So it's them that get to decide what they want supported. So I assume I don't work for Friction, by the way, but if someone goes to Friction and say I want support for this architecture, it can probably happen.
Any other question?
There's one there.
Yeah, I'd like to ask about something like related to the compliance. We do know that DCI PSS requires regular scans for the servers that the companies are currently using in productions. So my question is, like the OpenSSH, they released some new software and thanks for the Debian security trackers and being patched fast and reliable. The question is, they still scan for the version number on the TCP headers or
Yep.
whatsoever things that causing the compliance check is in failure.
Yep.
And since we already patched the correct version even with the backport, so what's the recommendation from you to this kind of things?
Perfect. I love this question because I see this problem a lot as well. Debian publishes the security tracker data in a machine-readable format. Any security scanner that is good enough is reading that data instead of guessing the versions. And so if you see this issue, talk to your security scanner and tell them that it's broken. They need to look at the data from the security tracker instead.
Okay, any other question? Last one? No.
So as upstream maintainer, sometimes I get some CVEs at my package, and they said, okay, we fuzzed your package and we found this, and this is an embargo. You have 1 week or 1 day to fix your bug, and then we will publish. And it's like a security company or something, and they want their CV to be praised and everything, and they are not actually helping with fixing the things. How can we fix that? Having security people actually help fixing security and not just find them.
So this is a big issue, and starting last year is a lot of it. The whole situation changed quite rapidly when a new way of addressing this became available, which is become a CNA, pretty much. So if a CNA is an organization that is allowed to release CVIDs, they work with Mitre. But the way it works is that, for example, curl did that. Curl became a CNA. Once they become a CNA, they are the only ones allowed to release CVEs for curl. So then they can cut down a lot of crap. Of course, if you're from a smaller project, it's more difficult, but a lot of projects are following this. The Python Foundation has done this already as well. And by the time they were doing this, it turns out someone released a CVE without telling them as well. This cannot happen again nowadays. The Linux kernel projects also did that. So you might consider becoming a CNA. Maybe you can work with other upstream projects and do it together as an organization. But that's really the only way you get to control what gets released as a CVE. And we are out of time now. Thank you everyone for coming.
Thank you, Simon. Thank you, everyone.